Welcome. My name is Julian Hofer. I'm from Hamburg, and who of you have been to Hamburg? All right, quite a few. So some people know and some people don't know that in Hamburg, at the government of Hamburg, we are very innovative. And today I want to talk about some kind of about AI in urban development and about how we a special use case for analyzing comments, and in our special use case it's about or you will see. So who of you have attended the presentation of Jamie, where he was talking about AI and rail claims, so on, or the session from Christoph, where he was talking about LLMs in general? Nobody. All right. No problem. So because I have some slides about how LLM works on a very, very high level. So, and Christoph told it in another way, not in my way. So just to be clear. All right. Yeah, a little bit about myself. I started with Drupal 7 during my PhD. So my background is in information systems. And then, yeah, I developed different portals with Drupal and worked at the university quite long. After that, because my base home was in Hamburg, I've decided to work for the Hamburg government, and yeah, here I am. So let's talk about, and obviously I like Drupal and also natural language processing, just where you put text into some kind of mathematical representation and compute with it. And I've done this quite a lot. I don't know when I started with it, but way before LLMs come up. So now for me, I've talked to some guys here. It's a very nice time. So what are we? Let's see. Okay. So I'm working for the Agency for Geoinformation and Surveying, and we are doing different stuff. For example, we do surveying. So like sometimes you see some people on the street with, looks like a static, I don't know how to say, measurement. So, and they survey everything. Also, we surveying with satellite data and so on. We also do some mapping and aerial photos. So this means that in Hamburg, every year a plane is flying over Hamburg and take pictures and laser pointing pictures, and we collecting this data, and also we provide this data for free. So it's always open data, because our philosophy is to open source and open data. Sometimes it's a little bit restricted, but just in case of GDPR things. We also do a lot with data, and especially with geodata, so data that is some kind of georeferenced. And also one thing is real estate cadastry, where you can go to us and say, okay, please tell me how worth my house is, for example. Yeah. So, and that's why we love the management of urban data. And we have in Hamburg our urban data platform, it's so called. And there we have data owners. Sometimes it's the city of Hamburg itself, yeah. So for example, the water supplier, or yes, I don't know, public transport or something else. And we also have different departments in our agency, which are all working for this open data platform. And this open data platform, you can think like it's a hub for every urban data, and we try to provide everything of this urban data for free. So, and one department is the department Urban Data Hub. So where I'm working on, we are doing research and development in different tasks. Yeah, we do some technical, some infrastructure. Also, we're doing consulting for governance, data-driven innovations, and AI, and advanced analytics. And actually, this is my sub-department, and I'm specialized for natural language processing. But we also have the Department of Urban Data Platform. They just working on that the platform is working. And also we have the Department of Urban Data Solution, and they are working on different kinds of software solutions. Like, for example, we have a geo-information system. It's called Master Portal. It's also open source. Very few cities in Germany are using that. We have COSI, which is, it's a planning tool for planning social infrastructure. We have DPAS, and I will come to DPAS later on, because we're talking about that. DPAS, it's a participation tool, and it's based on Drupal. So the backend is in Drupal, and the front end is the Vue application. And we are providing dashboards about our data, or the Urban Data Solution is providing this. And actually, I was working before at the Urban Data Solutions department for DPAS, and developed DPAS with my colleagues. And then I changed to Urban Data Hub because I was thinking all the data that is in DPAS are very nice data set to analyze. Yeah. So our working field at Urban Data Hub at NLP are very different. We are working with large language models. We're working just really basic NLP tasks. We are working on consulting how to label data and how to train data. Also on ethics, and we are now at the moment developing some kind of ethic guidelines for our city, for example, for the AI. And today, and all this is some kind of it's connected in a project. It's called DPAS Analytics, and also we do some other stuff like comment analyzing, but actually it's also connected to DPAS Analytics because the data comes from DPAS. Well, we are also doing some kind of next level geoparsing. Next level geoparsing is like you have text and there's some kind of location. Yeah, for example, it says a really simple example is in Barcelona. We go out to the beach. So Barcelona is the location, yeah. But it can come very, very different. For example, in our participatory data, we see that people often speak about something, and they can do a pin on a map, but we see that the pin on the map is not related to that what they are speaking. So that's what meaning by next level geoparsing. And also we are doing chatbot development just to so that you can chat with our urban data and so on. So okay, this was the organization part. Now it's coming the really nice part. All right, before I have to talk about a little bit about DPAS. DPAS is a participation tool, and this means that in Hamburg you have by law this rule that if some government or some district government wants to build something in the city. They have to came up before with a participation, and it's called participation proceeding. And this participation proceeding is informal, so it means that if somebody of the citizens says, "I don't like this. This is good for us to know, but it's not. It means not. It has any kind of legal, legal connection." So, and they do, some advertising, though, that the citizens know, okay, there's some participation going on, and this participation is online and offline. So there's a system which you can just call. You can scan the QR code and you come to this site, and then you see, okay, it's about, I don't know, for example, here it's about bicycle parking in Altona because this is a problem in Altona, and you can participate and say something about that. So you have this form where you contribute, you enter your title, you enter a category. This category is predefined by the proceeding owner. We call it proceeding owner because every proceeding is different. Yeah, and they want to filter the content. That's why they put it there. Sometimes they can config that they want to choose also a type. And then this is the difference between every else participation systems in the world, or I don't know in the world, but at least in Germany, they can put, or they have to put a georeference. So they have to put a point, they can put a polygon, so to mark a district, and so, or a line to mark a street, something like that. And then we have this data, and we can show it on the website, so everybody who wants to know what is going on this participation can see it. Yeah, so you can see here this little pins and the contribution itself. Yeah. So this is the system we are using. As I said, in the backend it's Drupal, and the front end it's decoupled. It's a Vue.js application, and it's used very lot. So we have really amount of data. And this slide is actually old because I looked up yesterday, and it's now about more than 50,000 contributions. Yeah. So, and 50,000 contributions and 25,000 comments. So it's really a lot of amount of data, and you can see it's all distributed over. So this is Hamburg, if you don't know. Yeah, you can see this map, and it's distributed all over Hamburg. So there are different proceedings and so on. Yeah, and because this is so overwhelming, and the workers in the district have to analyze this data and its text data, we came up with our project Deepest Analytics, and the goal of Deepest Analytics is to develop an AI-based system that supports urban developers. Yeah. Our philosophy, as I said, is we want to use open source, so we are also using open source models, and our plan is to provide these AI services with an API, and since we are in the geo field, we are connected to this OGC processing API. Yeah, but it's a standardized API, so you can then use it. All right. So now I have a little bit of background about the project and so on, and what's my work. Let's talk about large language models, because as I told you, we are using large language model as well. What is a large language model? Actually, large language models came up, I think, or the most people are knowing them with if ChatGPT 3 came up or ChatGPT came up. Yeah? But actually the development was much longer. So in 2008 there was, I mean, you cannot call it really large language model because there was much smaller, but the idea behind it is very similar. And yeah, you can see that there are different kinds of models that are growing. That's what this tree is showing. And actually, you can think a lot of a large language model. It's a very big model which was trained on a very, very big data set. Yeah, so this was scraped, for example, the whole Wikipedia, newspapers, forum sites like Reddit or something else. And behind the large language model is always a so-called deep learning network, because this network is very, very large. Or you can see here 96 layers. Actually, also this slide is old because now I think it's about 150 layers or so. So there are bigger models and it's growing up. So yeah, but the thing is the same. You have a large amount of layers and a large amount of parameters, and by parameters I mean just input nodes. Yeah, and you have it's a neural network, so it's like you want to, or the idea behind a neural network is to kind of simulate the human brain. So more this neural system, just so if you go there, or if the data goes in, some kind of magic happens, and mathematically these nodes are turned on and turned off. Yeah, so that's a very simple explanation of a neural network. And these large language models have the task to, or they are predicting the next token. Yeah, and to simplify that, we are just thinking about they predicting the next word. And I have here one example. You can think like you have, for example, here you give the question, what is the LGB? And LGB is the abbreviation for my agency. In Germany, it's Landesbetrieb Geoinformation Vermessung. That's why LGV. And yeah, so you have the LGV, and then the model is looking up which can be the next word. Maybe it's builds, maybe it's creates. So, and it looks up in the data and sees, okay, creates is more often in the near of LGV. That's why the probability of creates is higher than builds. And then it looks up for the next word. Yeah, and because we are doing mapping and mapping information, it looks up in the data and sees, okay, maps, LGB, and creates are related more because they are nearer in the data, and that's why the probability of the word maps is higher. And this goes on and on and on, and the principle is always the same. Yeah, the only thing new in relation to, I don't know, 2018 is we have a very, very long context field. Yeah, before it was really hard to see which words are in the neighborhood of it, because you could only see maybe 3 words back and 3 words forward. So, but now this is, yeah, I mean, it's very, very nice now. So, yeah. Okay, so keep in mind this is just this very simply explanation how a large language model works. Yeah, predict the next word. Actually, it's predicting the next token, then it's more smaller, but predicting the next word, you can work with that. Sure. Yeah, and in DPass, we have this contribution, and we also have comments. So you can comment on a contribution. And I've here one example. It's talk about hostile architecture. Yeah, so it's an original data. So it's located at the Drupal-Platz. This is some kind of place in Altona in Hamburg. I've lived there before, and the user is talking about yeah, because there is a scene of drug consumers. Yeah, so and this user wants to have some kind of architecture that avoids them. So yeah, and because we have this comment feature, other participants can comment on this contribution, right? And yeah, you can see, for example, here somebody says, hostile architecture as a suggestion, that's not good, yeah, for example. Or very sad, very, yeah, not human friendly, yeah. Or something said, a very, very bad idea, okay? So, and we asked our users, which are analyzing these contributions, and if they are also analyzing these comments, and they told us, no, we don't have really time for that, because if we are going to this contribution, it's time consuming, and we are actually working on that, but the comments are just, if we are doing this, we only do it like, okay, we look at a comment and say, yeah, it agrees, I don't agree, yeah? So that's it. But this has a slightly problem, because if you have a contribution can have different key messages, yeah? So, and if you just say, okay, the comment is agree, so you say it will agree to all key messages. But that's not really the point. But if you see that or we see that in the comments, yeah, it sometimes agrees to one key message, but it disagrees to another key message, and so on. Okay? So that's a problem. And we looked up in the literature, and there is a subpart of sentiment analysis. Sentiment analysis is about polarity, usually, yeah? If you look up sentiment analysis, it's like, okay, is this phrase positive, negative, neutral, or something, yeah? So it's more about the emotion. But here, we want to look at what is the stance, yeah, of the comment in relation to the contribution. And that's called stance detection. And stance detection is really a good thing. So we have this comment, we have the key messages of a contribution, and we put this into a stance detection machine, yeah? So, and this machine gives us just, okay, it's approving, it's disagreeing, it's neutral, all right? So, and we came up with this idea because we asked our users, how do you do this process of analyzing if you are doing it, yeah? And as I said, they told us, yeah, usually we look like this, and we asked, wait, there's this problem. And they told us, yeah, okay, we know that, and it would be nice if we can just, yeah, split it in some way, yeah? So, or can do that. And so we asked them as well, how do you define key messages? Because for us, it is important to know how in their brain the model looks like, yeah? So because we want to train our AI with the data and also tell, yeah, the large language model how it has to act, yeah? And that's why we went to our users, asked them, hey, can you give us some kind of explanation how you would describe a key message? And they told us, yes, so actually it's some kind of phrase has a problem with a suggestion or a praise, and also for the comments, we said, okay, give us some explanations about what should be an approval, what should be a disagreement, what should be neutral, right? So, and as we collected this data, this was not one day workshop. It was a very iterative process because actually we did some kind of gold standard, and then we go back to the users, ask them, is that right, and so on. Yeah. After that, we created a prompt for a large language model to provide it with the data and the task. So, and this prompt is, structured a little bit. For example, it says, okay, you are a helpful, respectful, honest assistant of an urban development planner, right? So because we want to guide the model in the direction of urban development, right? That's so, and also we say, hey, look, we have these definitions, and these definitions was coming by our users, yeah? So what is the problem? What is the praise? What is the suggestion? We also say, okay, please extract the key message in German, do it only in stick words, be sure it's a problem, a praise, or a suggestion, and so on. Also, this prompt is not just one day work, it's just a very iterative thing, yeah? And then we put in an example. So just the one shot. It's called one shot prompting. So that the model knows, okay, which concept it should look like. Yeah. So for example, here's the example for the model. You have this contribution and you have this key messages. Yeah. These key messages are in this contribution. All right. So the model knows, okay, this concept I have to look up. Yeah, and then in the main prompt, we just give one contribution, and also, actually, here you can't see that, but also the comma, no, at this moment, just the contribution to extract the key message, right? Because we have a two-step approach. Firstly, we extract the key messages, and secondly, we are doing this stance analysis, right? So, but then the question is, are we good at this task? And as I told you, we're in a very iterative process, and we created some kind of gold standard. So we draw, I think, 700 samples from DPOS. We said to a human, she was working in urban development, please extract key messages from these contributions, from these 700s, and just put it in an Excel file, right? So, or in a table. And then we give the same data, the model, and said, or the same task, extract the key messages. So, and then we came up with the idea, okay, how can we see if it's good or not, right? So because you can see here, you can see it. So for example, the human people says, Kinder müssen Fußweg falsch nutzen. The machine says, gefährliche, very dangerous Querung, so you crosswalk about the street by children, yeah, right? So the one sentence is very short, the other sentence is longer, but actually they are talking, I think, they're talking some kind of the same problem, yeah? So, and we decided to go with a metric called BERT score. BERT score takes the semantic similarity between two texts, and then it calculates it. Yeah? So we just calculate the BERT score for every of these rows, and also we did then the meaning and the mean, the average, and we came up with a F1 score of 85%, which for us, it's good. So, I mean, you can work on the prompt and get it better and get it better. So, but for us at the moment, it's good because we are just working on that. And actually, it's like a kind of side project for me, yeah. All right, so this was the first task, to extract the key messages. Second task is the stance extraction, yeah. And then we give this task also to our urban development human, and she did the same thing like the model, yeah. Just she get a common text and the contribution and the key messages, and has to say if it's agreeing, disagreeing, or neutral to it, right? And then we thought about, okay, how can we measure this one? And we said, okay, actually, it's like the same task if you, and as I said before, we are also consulting if you're creating training data sets. And there's so-called Cohen's kappa. So it's a rater metric, yeah. And this Cohen's kappa tells you, yeah, how good two raters are rating the same thing, yeah. So, and this is the value for this task was 60%, and 60% is substantial, yeah. So there are different classes for this Cohen's kappa, and 60% are very substantial. So we said, okay, this is good. It's not bad. It's not very good, but it's okay for us. All right, and then we went back to our users with some mock-ups, because now we have all this AI stuff done, and how we can present it, to our users. So, and the architecture is, I won't talk very long about it. It's like we have a Drupal backend, and this Drupal backend also, there's all the deepest data in it. We have an AI server. Actually, as I said, we are very innovative. It's in the basement of my office. And we send the data and the task to a large language model. It's in Mixtral 87B. And it puts back the information to the Drupal side. We are currently working on it to make it more standardized so that it's confirmed with the OGC API processes. And as I was developing this part, there was some timeout issues, because sometimes it was like, okay, it's a big contribution or it's a big comment, and the model was calculating and calculating and calculating. And in my implementation was like, request timeout. So, okay. So I thought, in Drupal, we have this batch API, yeah? And this batch API you can use to chunk a process in little chunks and just give one of these chunks to, for example, this model. And it's very good, actually. And also, it's asynchronous. So you can start this batch, and it's processing in the background, yeah? And so if you look up batch API in Drupal, you will see some examples. For me, it's okay documented, yeah. Actually, what I've done is just to chunk my NIDs, and with NIDs I mean contribution IDs. So one NID is just a contribution. Then I sent it to a function called analyze comments, and this function is just sending the contribution and the comment to the large language model, to the AI server, and waits for the answer. All right? And after that, it's just saying, okay, so you see in this for loop, there's the batch operation, and then you say, or you give some metadata for the user. So Yeah, and also if I've tried that here, but the internet was very laggy. So, and because I'm using this HTTP client in Drupal, it's Guzzy, I think it's Guzzy. There is a timeout thing about 30 seconds, something like that. So actually I had to increase it to 100. So that's why here I show you that. But usually it works fine. I think if you have a good internet connection, it will work fine just with this 30 seconds delay. And then it also, what I really like is, wait a minute. I mean, I've very cut this because it's taken, I think, 2 or 3 minutes. Yeah. So, but what I really like is you have this progress bar. You don't have to worry about this because everything is there in the batch API. You just have to implement it, and for our users, it's okay. So, all right. Yeah, and then we developed a tool. So yeah, I go there to comment analyzer. Then you see all these contributions. Yeah, I'll go to the contribution I showed you earlier, and then you see the contribution. You see the key messages here, the 3 ones, and you see the comments related to the contribution, and you see some kind of distributions of the stances so that our users have an insight about this, right? And if you're clicking on one of these comments, you can see more dive in. All right. So yeah, what's next? Actually, I had no time to implement this human in the loop, but for us it's very important, and also our users said that we should do some human in the loop because the model is not always right. Yeah, and that's why the next step is to implement that so that the user can say, okay, this is not right, please change it. No? And also for us, this is a very, very good information because we can take this as a new example, give it a model and make it better. Right. Tweaking the model to explain itself means that now the model gives no explanation why it has extracted these key messages. Yeah. In my current project, where we are working on analyzing these contributions, and I showed you this category. And for example, we have this task to extract a category of a sentence, and there we guide the model to explain why it has chosen this, and also to say, give a score or give some kind of, yeah, I'm really sure, likely sure, and so on. Yeah, so that we can give more information to our users. Yes, evaluation of our module. So also analyzing threads, because now it's just looking just at the comments that, not at the comments who are commented to a comment. It's only looking at comments who are comment to a contribution. Yeah, but sometimes we have this. It's a comment to a comment. Yeah, so it's like it's a thread. Also, we didn't try it with Llama 3. We have tried it with Llama 2. And with Llama 2, there was this really weird thing that we just give it the prompt, but it tends to answer in English. So I don't know why. So even we said, please answer in German, and it just answered in English. Sometimes it's answered in German and sometimes so, but that's not good for us because we couldn't work with it. Yeah, lessons learned. Evaluating is always a good thing. So yeah, as I told you, for us it was always a question how good we are at things and also at this at this kind of analyzing this data. For non-English evaluation, if you want to do some kind of stuff, well, what we have done, you can use the BERT score and the BERT-based multilingual case. It's recommended for non-English languages like German, French, something. Yeah, as I said, Llama 2 tends to answer in English. And also some props to one of my master students because he has done also some work also, yeah, just to take the interviews and just to create prompts and yeah, relation with me. And I was consulting him for his master's thesis. Yeah. So, questions?
Hi. That's a really cool idea. I like that. I'm dealing with large language models at my company too, just for POCs. And you said your large language model is running on a computer in your basement in your office. Is it what hardware are you using? Is it a large language model which is capable?
Yeah. So, okay, it's really an AI server. So we have two A100 GPUs at the basement. So,
okay.
So yeah, as I said, we are very innovative, and yeah, so we thought because we want to want to work with open source and open data and so on, and yeah, so we decided to buy two 800. Actually, it's not only for large language or for text analytics. For example, we are also doing image recognition. So, for example, like where to put solar panels on the roof and so on for the city, and some kind of other stuff. So it's not only for text analytics, but we can use it for that as well. Yeah.
Okay, and just one follow-up question: Is it productive or is it a POC?
At the moment, this one, so this comment analyzer is a POC, but so my deepest analytics project is scheduled at mid of 2025, and then some kind of it is productive in this DPass. And this DPass tool is also open source. So, yeah.
Okay, thank you.
You're welcome.
First, thank you for like a talk which was not just sort of like high level. It was very nice to explain for you that you explained like the different steps you did in the way. So I have sort of two questions. The one, like, do you have sort of thoughts about how we could use maybe the APIs which will be available in like browsers? Like I know Chrome will like probably ship with like an LLM by default, or like, you know, phones will probably have some. Do you have like thoughts how we could use that, like in your project, directly?
Yeah, so maybe we can, it's a good question. So maybe we can use it for example, I think also the models are getting better and better, and then you can have smaller models for the same task and so on. So, and at some point, there will be some kind of, you can, for example, get this key message extraction just with the API from the browser, yeah, for example. So, but the stance analysis maybe, I don't know. So, yeah.
Oh, it's interesting that the stance is the more complex process.
Yeah.
Oh, interesting.
Yeah.
Because that's just 1, 2, or 3, right? It's like sort of just.
Yeah,
Okay.
but
Oh, that's interesting. And the other one, right? You talked about how you evaluate all of this,
Yeah.
right? But this is like a manual process, like almost like a one-off process. It seemed like. Like, how do you like make sure that like future updates to like the prompt or anything in the system?
yeah. Actually,
it doesn't make it worse, right?
Yeah,
or does
yeah,
it actually make
yeah,
it better? I'm
yeah,
curious what your thoughts about
it's
this.
some kind of trade-off, because I have to go in my department actually to find someone who just evaluate this thing, so this human evaluation to create a gold standard, because I'm always saying, hey, we need some kind of gold standard, and the people are saying, yeah, but we have AI, why we need some kind of gold standard? And I say, yeah, but we just have to evaluate this. So yeah, it's actually this evaluation, it's, if you have done it, actually it's outdated. So right, yeah, but, or not outdated, but if we want to use another model, actually we should do the same process and so on, yeah. But for us, it's more like, are we in the right direction? So it's like some kind of soft evaluation, if you want so. Yeah. All right. Any other questions?
I have another one. There's a framework called DYSP, not sure, or DSYP. I didn't use it yet, but like it's sort of an idea that the prompts are, that you don't create the prompt, but rather it is a framework for evaluating prompts over time and generating the prompt for you, like sort of like finding the right prompt.
All right.
Like, have you experimented with anything? Like, so what was the process of finding the prompt, which was useful for you at the end?
Yeah, really talking with the end users. So just to get their mind model about their analyzing task. And then we tried it in the area, just with different models. And
Did you do any prompting techniques there? Like any tips there? Like,
yeah, I mean, here we just said we only need really this one, not kind of chain of thought or something. If we go with this kind of explanation and so on, it's more feasible, but yeah, here we don't. All right. Thank you.